Hello there. Today I hope to teach you a little, or not teach you, but give you a little basic introduction to acceleration. So, let's just get started. Basically, acceleration is just a measure of how much velocity you gain in, for instance, in a period of time. So, for example, you gain 1 meter per second of velocity every second, then that would be an acceleration of 1 meters per second squared. So basically, you can define acceleration as the rate that your velocity changes, right? And people have condensed this into quite a basic formula, really. It's this. It's A is equivalent to the V minus U over T. So all this means is that your acceleration in meters per second squared, how much velocity you gain every second, is equivalent to your final velocity. This is the velocity you end up with, minus your initial velocity. And this is just going to be over the time taken for you to reach that to reach that final velocity from that initial velocity, right? Okay, so let's try a little fun problem here. So let's say we have a car here. This is a car. Remember, in physics, we don't really need to draw the actual car. We can just draw a box, right? So let's just say it's traveling this way, all right? This car is traveling this way. And I'll just draw the start and end points. Start, end. Okay. So now, if this car, let's just say this car took a period of 2 seconds to reach its start and end points, and at the start, its velocity would be, for example, 2 meters per second. And let's just say its end velocity would be 10 meters per second. How do you think we'd calculate acceleration then? I'll give you some time to think. Alright, so if you can figure out a way to plug all these values into this formula, then you'll be able to figure out acceleration. So it's actually quite simple. So your acceleration, actually let me do it on this side so it's a little more clear. So your acceleration will just be, your final velocity. This means your end velocity is just 10 meters per second. And what's your initial velocity? Well, your initial velocity would be 2 meters per second. So minus 2 meters per second. And what's the time taken? Well, it's the time taken to get to the final velocity from the initial velocity is, 2 seconds. Right? So then, what you're gonna get is your acceleration is just going to be equivalent to 8 meters per second over 2 seconds. Alright? Which is also just going to be equal to 4 meters per second squared. Simple. Now, recall that this is just how much velocity you gain every second. And in fact, let's plot a little chart of this car as it accelerates. Let's plot a little chart. So we have t. This will represent time in seconds, and we have our velocity in meters per second. Okay, very good. Let's draw this. We don't need a big one. All right. So what would our velocity be after 1 second of acceleration? This is assuming that acceleration is constant, by the way. Alright, so at t equals 1 second, our velocity will just be, well, 2 plus 4 meters per second. That would just be 6 meters per second. Alright? What about at t equals 2 seconds? Well, if we gain 4 meters per second every second, then at 2 seconds, we're going to be at 10 meters per second. And it agrees with this question. And it agrees with this problem. Right? Okay. Very good. Alright, I'm going to show you some other ways. Or no, actually, let's just do one extra problem, and then we can call it a day. Alright? So, let's see. Let's do another car one. Let's do another car one. And I want to say that its initial velocity is gonna be, I don't know, 5 meters per second. And then it accelerates. It accelerates at a rate of 2 meters per second squared. And then it has a final velocity of, let's just say 25 meters per second. Right? Okay. Now I want you to calculate, or let's see if we can calculate the time taken for this car to get to 25 meters per second from 5 meters per second, and if its acceleration is 2 meters per second squared. I'll give you some time to think. Alright, I assume that you've tried it, and well, your first step would be rearranging this formula so that you can make time the subject, because that's what we're trying to solve for. Right, so let's do a little bit of rearrangements here. So A is equivalent to V minus U over T. So then you multiply T to both sides. AT is equivalent to V minus U. And then, well, if you want to solve for if you want to solve for T, T is equal to V minus U over A. Cool. Now we can plug these in, right? So, this is also just going to be equal to, well, what's our final velocity? Our final velocity is 25 meters per second, so let's plug that in. Our initial velocity is 5 meters per second. And what's our acceleration? Well, our acceleration is 2 meters per second squared. This is just going to be equal to, well, 25 minus 5, that's 20. And then 20 over 2 is just 10. So it would have taken 10 seconds, right? And it makes sense if you gain 2 meters per second of velocity every second, and if you keep on maintaining that, well, you're gonna get to 25 meters per second from an initial velocity of 5 meters per second in, well, 10 seconds. Now, just one thing to maybe know about, or not know about, just to, I don't know how to put it, just to like, for the more sharp of you guys, for the people who have a better eye, you will realize that acceleration is the final velocity minus the initial velocity over the time, right? Well, another way of thinking about it is that acceleration could be defined, you could technically take acceleration as the change in velocity, delta V, over the change in time, delta T. That's another way of thinking about this formula. And in fact, we can graph this car's acceleration. But I think that will be for a different day. So anyway, I hope you've gotten this basic introduction to how to apply this formula, and I hope I've cleared up any problems that you guys have had. All right. See you in the next one.